ready to go.
Oh, we are? Okay.
Yep.
Okay, welcome to our web discussion. This will be the last one until January 26th, which will be almost the 30th anniversary of a major thundersnow event here, where we got like 5 inches of snow in an hour in 1996, but that's another story. We are starved for snow here. It's kind of starting to get to be, I don't know, critical, frustrating, however you want to describe it. And it's not going to be relieved in the next several days, I'm afraid to say. I'll just let the cat out of the bag. But we do have some really interesting things brewing right now. And from a conspiracy of seemingly small, low-profile circumstances that I think the current weather and then Patrick's forecast discussion will make clear. I hope that's what we do today. So, starting with the satellite image, we see a couple of really interesting features. One is this beautiful little cyclonic swirly over Kansas, Oklahoma, parts of Texas. And of course, that's what's responsible for the invasion of clouds in our sky today. Started out, Pete had the movie up from the rooftop cameras, a beautiful sunrise if you weren't up early enough. And then it just got kind of cloudy, opaque, gray, like it usually does in mid-December. And so that's associated with this development, so we'll talk a little bit about that in the current weather. A somewhat unseen development that's currently over the western part of Hudson Bay and moving across the southern part to James Bay is feature number one that will conspire to produce a really intense anticyclone over the North Atlantic by about, I think, day 3 or 4 or something like that. Is that right, Patrick? 96 hours? And so we'll talk a little bit about that as an antecedent condition. And then finally, the third feature is this really intriguing looking cloud mass over this sort of central and eastern part of the Gulf of Mexico. As you might be able to tell, it looks convective from its perspective on the infrared satellite image. It has the spokes that Tripoli always talked about, and they're kind of rotating in a clockwise fashion. So there's something about an anticyclonic rotation aloft that is embedded within that really interesting collection of seemingly tropical looking clouds, not yet organized. And then that's all trailing at the southern end of this extraordinary cold front. I think that probably part of the cold front that's way up over it, the storm's up over Iceland east of Greenland. So that's an interesting development, and a little puff going across the southern part of the Labrador Sea. So in a nutshell, this feature turns into a major rain event for the eastern United States, all the way up to maritime Canada in the next 3 to 4 days. Meanwhile, an anticyclogenesis agent comes out of Ontario into the North Atlantic, gets an anticyclone going, and then the diabatic heating associated with this thing, I think, really turns it into a fairly impressive anticyclone. So it's a really nice, not only combination of pure adiabatic and then diabatic components, but also extratropical and tropical components. So I think that'll be kind of a fun focus for the discussion today. I'm going to take the front end of that, and then Patrick will do the forecast on that. Okay. So that's where we are in the broad setup. So Pete, if we could, let's go to some super Petes right away. And let's start at 500 millibars. So it's the 500 millibar map for this morning at 7 a.m. And it's modestly wavy across the middle part of the North American continent, just north of us. I mean, here's feature number one. Remember, we had our nice swirly right in this location. That's tied to this upper level trough feature. But it's not a very strongly baroclinic feature. It's minus 16. I guess it's minus 10 in Amarillo. That's relatively warm. But broadly speaking, from the mid-teens to about minus 20, minus 21. So not a lot of baroclinic contrast associated with this feature. There's only one isotherm. It's the minus 20 isotherm that's right in there. But it's a sharply curved feature, and almost textbook curved. I mean, if you were going to draw an example for an exam, if you had one tomorrow, you might use this as your upper trough axis, right? And then downstream there's not an independent ridge until you get way afar, and then upstream there isn't one either. So it's really ascent and ageostrophic divergence associated with the curvature of this trough all by itself, maybe a little bit of an assist with the anticyclonic curvature to the north over us. But that nicely explains, and we'll see it in a couple of diagnostics, nicely explains the presence and location of the feature that's over Kansas and Oklahoma. And then what's also interesting is this broad northwesterly flow coming off the archipelago across Hudson Bay, and then a really strange thermal structure. It's minus 20 going all the way up to here, and then this is minus 30. And so one wonders what concentrated that horizontal temperature contrast. I don't have the answer, and I'm not going to go backwards to find it out. But I can tell you that as a consequence of its presence, and maybe also here in the eastern part of Hudson Bay, there's some really strong and localized cold advection at 500 millibars. It's more dramatic, lower down, as I'll show you in just a minute. Let's go to 700 millibars peak. I should have done the radar, but we'll do that in a second. So at 700 millibars, the trough over the southern plains is a little bit less well organized. It's more just a northerly flow and then a southerly flow with a little bit of curvature over northern Texas. So that doesn't really suggest that, you know, the strongest forcing for the ascent that we'll see manifest in the clouds and in the radar is going on in the lower troposphere, probably in the middle or upper troposphere. But look at this horizontal temperature contrast and advection at 700 millibars across central Hudson Bay. First, extreme, well, maybe not extreme, but notable cyclonic shear. It's 50, 55 knots in this channel, maybe 35 to 40 in this one. So there's a positive vorticity maximum right about there. And then the thermal wind is about, and then a negative vorticity maximum on the southern side of that. And then thermal wind is about a proxy, or is parallel approximately to the isotropes. So there's pretty decent NVA going on in this location of shear vorticity by the thermal wind, and there's strong differential cold, not differential, localized cold advection over the central part of Hudson Bay, all conspiring to produce some pretty decent subsidence in that location. And that is of interest for later on in the forecast period. So this is the beginning of a region of fairly intense and continuous subsidence in the middle and upper troposphere. And you can see some reasons why that's the case right now. And remember we said we had that strong 500 millibar baroclinic zone at about this location. It's also strong at 700. So that's a strong frontal characteristic in the middle to upper troposphere at least, maybe even further down than that. Okay, let's take a look now at the satellite, not the satellite, the radar it could be. So here's the radar. This is a beautiful presentation of this disturbance. It's exactly where you'd expect it to be. Remember the 500 millibar trough axis, strongly curved, is right about in here at 7 a.m. this morning. We're now several hours past that. But a really nice linear band along the front edge of this disturbance, and then a beautiful cyclonic swirl at the top, and a little bit of precipitation across the northern part of our own state, but mostly the upper peninsula and parts of southern part of the Arrowhead, Duluth area. And we'll take a look at the surface map in a minute. I think it's too warm to be anything but rain everywhere. But this is a really nice presentation, and it's the feature that has a bearing on our weather for tomorrow, that's for sure. Can we take a look at the surface map, Pete?
That comma cloud is gorgeous in the day cloud phase image I was looking at.
Oh, let's take a look at it then. I didn't look at that.
It's
Pete's fancy cloud phase.
yeah, just
Let's see what that looks like. Oh yeah, it almost looks haunting. It looks
Really
like something you see at the front of a haunted house at Halloween. Yeah, that's really neat.
So the reds and the yellows are higher level clouds. The cyan colored is lower clouds. Bright green usually is snow, like up in North Dakota.
Okay.
The darker blue is land, and black is usually water.
Yeah, that's very nice, isn't it? And you know, when you see these things sometimes more robustly developed, like out over the Pacific Basin or something, they have the exact same character. That is, the high clouds come up to a certain point, very often bifurcate intercyclonically, and then seemingly there's this lower cloud underneath it, and then even more lower clouds back in there. And that betrays, I think, the mechanism by which the whole thing forms. I don't think it's really like that. You know, there's people who think this so-called cold conveyor belt comes in poleward of the warm front and then rises as it gets near the cyclone. It doesn't rise. There's no ascent there at all, maybe a kilometer. The real ascent is forced by something else, dynamics that are part of the occlusion process, it seems to me. But why the clouds are so strongly bifurcated is still of interest and probably needs more explanation. Trying to find the state boundaries. Here we are in the northern part of our own state right here, so you can kind of see that. Okay. Thanks, Pete, for bringing that up.
Surface map, right?
Where were we? Yeah, we're going to do the surface map just to see, you know, what's happening precip type-wise across the region. So, remembering where the central part of our circulation aloft was, first of all, let's try and see if we can't find anything at the surface. Here's some southerly winds and then some northerlies back in here, and I don't see any easterlies anywhere until I get up to almost to Minnesota, so the cyclone center is that far displaced from the, no, maybe it's down here. So here's some southerlies, there's a few light easterly and light winds. Maybe the cyclone center is along and around there, but it's very weak if that's the case. 1023.5, I'm looking for the lowest pressure, 1021.8 maybe is the lowest pressure in the region. And then up a bit further north where I might have mistakenly started thinking about its, the surface reflection, the pressures are even higher. So this is a weak surface cycle. I mean, it's, this sea level pressure minimum is about 10 or more millibars higher than standard sea level pressure. But it's raining across much of the region of Kansas and Oklahoma, and then spreading northward into Nebraska. Southern Nebraska has light rain. And then we saw that cloud mass across the upper peninsula in parts of Minnesota. That's all rain as well. Temperatures in the high 30s, pretty much everywhere in the central part of Minnesota, even warmer in the southwestern part of the state. So no snow at all from that feature across northern Wisconsin and into Michigan and Minnesota. And then widespread clear across the eastern, maybe third or fourth of the nation. So we'll see that. Okay, let's go from here to, I'm going to show you next. Oh yeah, I want to show you some vertical motions, quasi-dystrophic vertical motions. Oh, no, Pete, let's go there. Let's go there. And this is a whole another line. I don't care so much about this. I do care about the snow, though. That was interesting. Can you scroll up?
This is, I just wanted to refresh it, make sure it was updated today, which it is.
Yeah, so accumulated snowfall. It's snowed a couple of times here, but let's face it, it hasn't really snowed. And we are already at a pretty decent deficit, and it's not going to be alleviated in the next week or however many days, 10 days. Everybody's looking at December 25th. The official definition of a white Christmas is 1 inch of snow on the ground at 6 a.m. on Christmas Day. I didn't know that till this week. I always wondered about it. When we've had that, I think about 60% of the time in the last 25 years here in Madison, but we will not have it this year, I'm afraid. I don't think it's going to happen. The question is, with a robust El Nino on top of a late start, what will the season look like? I got a bad feeling about this. I mean, 50-ish inches is about what we get for on average. I don't know if we're going to get even this high. I hope I'm wrong. I really do hope I'm wrong, but I don't know. So we'll see. Then let's look at the cold pool, which is behind this screen, Pete. I've got a couple of slides up for that. Yeah, right there. So here is through December 14th, the time series for this year, and then a bunch of different averages that are labeled here in the black and the blue and the green. And every single day's maximum extent and minimum extent of the -5 area at 850 millibars around the whole northern hemisphere. And so for a long time, we were running second or third warmest, which means a deficit well below the average through September and October. And then November kind of climbed back to about normal, but for some of the days, I should say. But overall, and then December has had a dip below normal for the beginning of the month, all the way from September 1 to December 14th, we're the 7th smallest aerial extent integrated over all that time in 76 years. So it's been a warm spring, warm fall. Now, if we go to the next slide on this, which I don't know how you in advance, I just go that way. This is the beginning of the heart of the winter, December through end of February, and that's the same little tail at the end of the last one here. But the convention's the same, it's just a kind of a blow up of the aerial extent. Every day has a maximum and a minimum in the historical record. This is the average for the calendar day, and then plus and minus 1 standard deviation. So here's the time series from December 1 to the 14th this year. This is why we're climbing out of the highest ranks of the warmest years. As we go into it, we went from second or third warmest to 7th warmest all the way to this date, but that's because December 1 through 14th, the first 2 weeks of this December is the 29th warmest out of 76 years. So kind of right in the middle of the range. Nothing exceptional, nothing particularly unusual. Even though a number of days were quite well below the average for their respective calendar days. So December is a highly variable month, I think, by this measure. And that's what this testifies to, among other things. So the question is, where will we go from here? If we're going to have a no-snow winter, I want to break the all-time record, which was 1415, 2014. Andrea?
I have a question about just the cold pool.
Yeah.
How much is it shifted towards Eurasia? Just because it's continental regions are where you're going to see the coldest.
Yeah.
So
yeah.
in this time of year, how much of the variability comes from cold over Eurasia?
That's an excellent question, and it's a level of detail that we could recreate easily, but I've never done that.
Okay.
And so it would be easy to recreate it.
Yeah,
but
I know that I'm just looking at the big spike up in I think a lot of Siberia had a really, I don't want to say colder outbreak. 'cause it
Yeah.
wasn't, but it was pretty cold, and, you know, like 1060 high, cold air, that sort of thing. So I'm wondering if that signal is a lot of that spike that you see there.
Yeah, you know, I think there's probably a relationship between the Siberian Mongolian high, which you can measure.
Yeah.
And surprisingly, people have only measured it on the seasonal or monthly timescale. Why would you do that when you can look at it every day? And then how that varies with how this varies
Yeah.
would be quite interesting.
Interesting.
Yeah, and easily doable.
Yeah.
So if anybody's interested, we can work on it together. In fact, that could be you. I know how unbusy you are. You don't have much going on. But yeah, that would be really fun to do. And by the same measure, actually, you just take what I was doing years ago when I was measuring things about the Siberian Mongolian high. It's just, I think it was the 1032 millibar sea level isobar. Just measure the aerial extent of that. And you can do it the same method, and it expands and it contracts.
Yeah.
And so when it expands, you expect this to go up and vice versa. It's really fun. But so far, 29th warmest, only 2 weeks into about a 12-week season. So I'd like to see us get really warm if we're not going to snow, break the all-time record, but I don't have any hopes for that. I bet you I'll make a guess, I'll bet you by the time we get to the end of February, we're in the middling high teens to low 20s of warmest ever. And people are going to say, who cares? It's like finishing 8th in a tournament of 20 teams. Nobody cares. Okay, let's go back to where we were, Pete, which is I'd like to look at some vertical motion diagnostics from my Omega page, if we could. Because I want to get a grip on what's going on at this thing in Canada as a prelude to what Patrick's going to talk about. I don't think I did put it up. No, I didn't. Sorry.
You do Omega, right?
Yeah. And is it the new Omega? Yeah, that's okay. So let's do this map right here. Total Omega at 12Z this morning. So this, I know this is, it says forecast hour 12, but it was run at 0Z, as you can tell. So this is a 12-hour forecast valid 12Z this morning. And blues are subsidence at 700 millibars. Yellow's ascent every decipascal per second, and then 500 and 900 thickness is the dotted white lines there. So a major subsidence region over central Hudson Bay of, 6 or so centimeters per second of downdraft. That's substantial. It's really hard to make strong downdrafts because in the process of doing so, you increase the stability, which makes it harder in the next instance to keep the air going down. You can't move it in the vertical, so that's one of the many asymmetries between anticyclogenesis and cyclogenesis, but that might be one of the most compelling ones right there. So there's some strong subsidence here. We'll trace this a little bit into the future. Here's the couplet of vertical motions associated with our trough over North Texas and the panhandles of Texas and Oklahoma, and the ascent right in this location looks just like the storm we saw at Trollsy this morning in the satellite. And even a little bit of that, at least cloudiness over us, is maybe tied to an ascent region to our west. Okay, let's go to, I don't want to go too far in the forecast, let's just go to 24 hours in the forecast. And it looks as if this whole thing starts to fall apart, even though that's not quite true, and I just can't. I'll show you the 48-hour forecast and leave it at that. But it looks like it falls apart. Let's go to 48 a day. It goes into Sunday. It clearly doesn't fall apart. This is really intense subsidence. This is, where are we? We're off the coast of Nova Scotia, Newfoundland. So this is something like 8 centimeter per second downdraft, and it's concentrated, which is really rare for subsidence to be so concentrated as that. And so that is, and this thing's progressed from central Hudson Bay through a apparent weakening phase to an intensification phase. And I would suggest this is entirely extratropical. There's not really any influence at all from the tropics on the evolution of this feature. And I know I only showed you a couple of times, but you can watch that happen and you probably would agree. And it becomes a fairly intense feature right off of maritime Canada. If we could, let's go to Alicia's maps at, this will be only 36 hours into the forecast that's probably available here. Yeah, let's go to 36 hours forecast. Yes, this is valid at the same time, where we had a strong subsidence over maritime Canada and a sea level pressure of 1,036 or a little bit higher than that right here in the Bay of Fundy. So this is a purely extratropically driven anticyclone, an anticyclogenesis event. And the strongest subsidence is right where the thickness gradient's the largest, and that presumably is where the NVA is the largest, and it always leads the region at the moment of highest pressure, and that makes all really good sense. So this is a developing anticyclone, but it's entirely developing through the exegesis of extratropical dynamics. Meanwhile, what is going on with this weirdo feature that we saw over in the satellite picture over the Gulf of Mexico? This is 2 days into the future. It's starting to develop into a decent cyclone. That's where I'm going to leave. So that's all I have. And I bet you Patrick picks that up. So, any questions or comments? Okay, Patrick, thank you for doing the discussion.
Thank you for setting it up. So if we could start with my first tab, I'm using Tomer Berg's maps for the only reason that when I was trying to pull up the maps from our own page, they weren't loading. For whatever reason, I think it was my computer. So if we could step all the way back from this to the very start of this. And if we could go and just exit out of this for right now. And scroll down just a little bit, please. So what I'm showing you is, this is a look of theta on the 2 PBU surface. So you're getting a look at where are the tropics, where is the theta higher at 2 PBU, and where are the poles, polar regions, polar air, where is it lower on the 2 PBU surface. And I'm stepping all the way back, if you could scroll up so we could get the time, just so I know what time it is. This is Tuesday night local time. So this is a look at the setup, what I'll start with. And if we could go, click on this base layer, please, and go to overlays, and then go to surface, MSLP, and we'll put the highs and lows on there. One thing really cool about this website is you can overlay whatever you want fairly easily. And so let's scroll down so we have like most of the globe in the middle, please.
Patrick, I think you can zoom or peek in the very top, it says 100%.
Oh, yeah. Good call. I've never, perfect, thank you.
Oh, that's great. Yeah.
Nice.
Okay, so, and you can see here's the 2 PBU theta, these like whiter blue colors, you're closer to the ground at 2 PBU, and the reds are higher up from the surface. So to start, this is Wednesday, Tuesday night, we have an excursion of higher PV air closer to the surface down towards Eurasia. This is the Kamchatka Peninsula, and it's forcing the development. We saw a gigantic cyclone form in the Pacific, and this is the start of this feature right here. Going on in the Atlantic here, we have sort of the same excursion of PV, potential vorticity, closer to the surface, and it's forcing some sort of development as well just south of Greenland here. And so if we could step forward 24 hours, and it goes every 3 hours, we'll watch as these storms developed, both of them are bringing up this tropical air well into the poles. You can see that nicely in the colors here, and it's strengthened both of these low pressure systems. They're both around 950 hectopascal, maybe as a result of this, but there's definitely some other things going on which I won't touch on. But you can notice here, we have these really high theta PV values that stretch all the way up near the pole, and these are the same values that if you follow this all the way back are like characteristic of Florida in the southeast. That's how anomalous this air is, and the same thing's going on over the Pacific at the same time. And so if we could go 24 hours more into the forecast, you'll notice this tropical air gets lodged up near the poles, which is somewhere around here. Same with what's going on over Eurasia and Russia here. Both of these are going to set the stage for something that will develop that Professor Martin touched on and move off along the East Coast and then form anticyclone as well. So I wanted to set the stage. We have these 2 big wave-breaking events of tropical air getting lodged into the poles and then cut off from the main tropics and forming these really nice boundaries between the poles and the tropics. And so I think if we go to the next tab, I just wanted to switch. This was an old forecast here. Oh, no, here we'll go back, sorry. And if we could just switch the model initialization, and we'll do the current time now. And so you'll see this is the same time I was just showing. Largely the same. We have our first feature from the tropics and our second one north of Russia here. So if we could step forward from this 24 hours. Perfect. So now we're 12 UTC Saturday or 7 a.m. tomorrow morning. We see these two features are now completely cut off from the tropics which they originated, and they're forming these gradients between the tropics and the poles on either side, especially this feature that is very wonky. It goes from Canada, the same theta air, if you follow it all the way into Russia, and it has the sort of anticyclonic curvature to it, which I don't know, the dynamics of how this sort of feature would form. It's very weird to see something stretching all the way from the United States into Russia as one seemingly continuous feature, I would say, from this projection here. And then right over the poles is where you have higher theta air at 2 PVU, and so right over the poles you have this tropical air just sitting on top of it, and as we will see, this feature is dislodging any of the polar air that was originally over the poles, and once you have that dislodgement and the polar air going into the mid-latitudes is when you can get some extreme developments, and we'll see that here forecasted.
And I was just going to ask Andrea, does this
Yeah.
get you nervous?
Oh, we've been talking about it.
Yeah.
Oh, okay.
Yeah,
Okay.
I owe a lot of this to Andrea
Oh, it was
for
a
pointing
nice
this out.
amplification of wave 2
Yeah.
in the Pacific and the Atlantic.
Yes,
Yeah, man.
absolutely.
It's
Awesome.
really exciting, yes.
And so here's this pointing more towards the United States here. Here's that anticyclonic development that Professor Martin showed. This is 24 hours in the forecast, but we'll see this thing strengthen and move off over the eastern United States. And here's that low pressure of tropical origin maybe sitting over the Gulf of Mexico. So we could step forward now 24 hours from this look. We'll see here's our high pressure moving off the coast, strengthening slightly. Here's the low pressure developing. Now I believe it's 999 sitting over Florida. And you can see here's this still, this high theta air, tropical air sitting over the poles, and here's the one that was over Russia. And I point out the one over Russia because it's sort of making this boundary, this gradient between these theta surfaces on 2 PVU, which are, dislodging some sort of polar air over Canada, right behind this high pressure that's forming. And if we could step forward 24 hours again for this, please. We'll notice here's a very nice, excursion of this polar air deep over our own state, right behind that low pressure that was sitting over Florida from the tropical origin. Now it's 981, definitely a weather maker, and I'll show that here in a different look in a second. But right in front of it, you have a 1047 high pressure sitting over the Atlantic, which is weird. I've never seen something like this. This high pressure sitting over the Atlantic, especially since it's just been strengthening as it's moving to the east. And so I'll touch on why maybe some of this development might have occurred from my own perspective. And you'll notice here we have here's our tropical air. It's still sitting over the pole, but has begun to move this very low theta at 2 PVU. So this is high potential vorticity air closer to the surface, moving it down over the Atlantic and forcing yet again another development right ahead of it in between Greenland and mainland Canada at the same time. So there's a lot of things going on in this region just right off the eastern United States and Canada, all because of this, maybe not all because of this, but a function of that tropical air excursion into the poles here. And if we could go 24 hours more from this look, we'll see here's our storm. It strengthened down to 980, and then we're beginning to weaken. We still have that very nice feature of polar air protruding down towards the continental United States. And here's our high pressure. Now it's 1051, so it got stronger in the same time as everything's going on to its west here. And we still have this cutoff high tropical air just sitting over now it's not over the exact pole, but it's still relatively close to the pole and in the Arctic Circle. And then, sorry, I'll just go like 12 hours ahead, please, Pete. I'm going to point out that dislodgement of the this really high or really low theta PV air beginning to form another development right off Greenland, and this storm becomes 960 and is highly impactful for Iceland and the UK. And then right next to it, 1052 high, sitting over the Atlantic, and not moving that much, but strengthening as it just sits here and rotates.
Well, look at the scale. I mean, this is where the scale of the anomaly matters.
That's right.
It's so big and so negative that it's it's not going to go anywhere. It's
That's right.
800-pound gorilla in the Atlantic.
Funny, you should have pointed that out. It's almost like we rehearsed this. We could go to the next tab. Here's a look at what is now showing. So it sort of switched the projection. Here's the Atlantic, and here's the eastern United States. This is looking at sea level pressure, max and min, and their relative percentile rank. So this red into the pinks, this is the highest pressure that has been recorded for that location at that time, and then into the purples and blues, that's the lowest pressure that's been recorded for that location at that time. So this is looking back now, I think it's the hour 0. If we could step forward 24 hours, we'll just watch the same development as I just showed. So we'll get a look. Here's our high pressure forming. Here's the system over from the tropics. It definitely originated from the Yucatan, maybe further south of that. We'll keep going 24 hours. And we'll see now things become interesting. We develop this is the record maximum pressure for this location at this time. In all of the records, I'm not sure what the record is, the data set is used, but at the same time, this is the record low pressure, just, separated by a couple hundred miles at the same time.
I'll say that's the time when we had that intense subsidence at 700
That's
millibars
right.
from the QGO wagon.
That's right.
Right in that spot. Boy.
And 1042. All right, let's see what else happens if we go 24 hours now.
Look at that.
Now this region expands. We have a large portion of the Atlantic Ocean. This is the highest pressure that's ever been recorded for that location at this time. This is the lowest pressure that's ever been recorded for this location at this time. And look at the pressure gradient, 1047 to 981. So this is going to be a mess of weather for the eastern United States, and they just had a mess last weekend. And this is happening, sort of the exact time frame where it was Sunday into Monday is when they got their heaviest weather. This is definitely going to be sort of the same picture, but the change is that you have this record-breaking high pressure sitting just to the east as well. If we go 24 hours now, this area just expands. I mean, this is a very strong signal of, this has persisted at least from Monday till Friday. This storm is going to be record-breaking, and the expanse of how record-breaking this high pressure is, it almost spans the distance of the entire eastern United States. That's how large this is.
Somebody decided to go to the Azores for Christmas this
Yeah,
year.
that's
And
right.
they're really happy they did.
Yeah.
That's right.
You know what I mean?
You're sitting right here, it's sunny, it's
Oh my
80
God.
degrees or whatever. Must be nice. And then we can just go 24 hours more. We'll watch it decay slightly, but I mean, it's still, you still have record-breaking pressures lasting for 48 hours
That's amazing.
over the Atlantic. Okay, now let's go to the next tab, please.
And I don't know if I'm stealing your thunder, Patrick, I'm
Yeah,
sorry
no
if I am. I think the diabatic contribution from this thing that crawls up the East Coast has to be a major player to get you from 1,043-ish to 1,052.
Absolutely.
Yeah, and it actually symmetrizes all of the diabatic heating and the negative PV, makes
Absolutely.
it stand there.
Absolutely.
Really cool.
Yeah. If we could go to this overlay again, we'll just add on the highs and lows first before I say anything. And then surface and MSLP, and then the lows and highs here. And so this is starting again back at this morning, and now we're looking at 300 hectopascal heights and winds in the color shading. roughly the jet stream level. So if we could step forward 24 hours, we'll see here's our anticyclone. It's on the anticyclonic shear side of the jet, although it's not exactly certain if there's two jet features or one from this look. It's sort of in between two jet streaks within a larger just jet feature persisting over the Atlantic. If we could go 24 hours now, or ahead, you'll notice this feature kind of sits on the just upstream of a ridge. And so definitely there's diabatic heating going on. Here's our low pressure over Florida, but it also strikes me that you're in an area of ageostrophic convergence. Although maybe weak because you're not exactly, this would be the best region to be right where you're at the gradient of the winds, and then this is your true ridge feature. We're kind of divorced from that, but there's definitely some sort of large scale descent going on just from the ageostrophic convergence.
Yeah, I imagine
at that region.
Right at the base of the downstream trough from the anticyclone, that's really strong ageostrophy headed back towards Newfoundland. And then
Right.
if you've got modest,
Right, that's
super geostrophic flow across southern Canada and northern Maine, that's all you need to get a huge amount of convergence.
Definitely.
And that's where that maximum subsidence was.
Definitely. And if we keep going 24 hours, we'll see it persist in that location. It moves along. Now it's sort of, this is definitely favorable. Now you have, here's your ridge and then a downstream trough. You're right in between that, exactly where you would expect that upper level convergence to occur. And then 24 hours ahead of this, this is when it reaches its max peak. And this, look at this ridge. This is very, and the downstream trough too. You have just gigantic Rossby waves over this location. No doubt a function of what's going on in that development over into the Florida, the record-breaking development of that eastern coast storm and then this anticyclone as well.
This is a perspective that gives me a couple of thoughts, maybe insightful ones, about what's going on with the rapid decay then of the anticyclone. I think that the ridge that grows all the way into southern Greenland just creates a straight across the Atlantic jet, and so
Right.
there's no more anticyclonic flow.
That's right.
In the next times at that, and then the thing just stops for upward convergence.
That's right, yeah. If we just step forward maybe 2 or 3 clicks, you'll see, it slowly
The jet
decays.
goes
Now
right
it's-
across the North Atlantic now.
And now you're sort of in this no man's land of your highs are stacked on top of each other and you just fall apart. But you're still at 1052
Yeah, it's
hectopascal,
amazing.
so it's just amazing.
Yeah, if you're flying to Europe for Christmas.
Yeah, you're gonna get there.
Yeah.
Yeah, that's right.
Get on a plane at New York and
That's precisely the route you take, too.
Yeah, right.
It's exactly the right
Right.
set of circumstances.
yeah, so hopefully there's no major delays with any of these systems. I don't know.
Well, I wonder if the airlines relax a little bit and say,
They
hey,
could.
if you're on the ground for 45 minutes, it's not gonna matter. We'll make it up easily in the air.
That's true.
So they don't care, That's
Yeah.
maybe that's the worst part about traveling with these kind of conditions.
That's a good point, yeah. And then my last look here, I wanted to do the oft neglected NVA by the thermal wind potentially. We can see that here. And it's hard because not a lot of websites plot the negative vorticity. So if we could go to overlays here, and we'll do 2 things. First we'll do surface, and the MSLP, and then the lows and highs. And then I believe it's under diagnostics. No, maybe it's an upper level. Yeah, there we go, thickness. We can overlay the thickness as well. So the thickness is in the dash contours with the blue line is the 540, maybe it's the rain snow line. It's just one of the values. We have vorticity at 500 in the color fill, and then the geopotential heights are in black here. With the sea level pressures also analyzed. So we'll go 24 hours now. We'll get to the start of the analysis. So here's our anticyclone. We have a pretty decent gradient of vorticity. You have higher vorticity to the east, lower to the west, so you could maybe make a case for NVA by the thermal wind, negative vorticity advection, right where the cyclone is located, although it's, can't be sure because this isn't plotting any negative vorticity. It's just that you go from really positive values to no positive vorticity at all. that might also be conspiring to cause some large-scale descent right where that anticyclone is located. If we go 24 hours now ahead, so now we're at 48 hours. You can see two things. First, we're kind of, in no man's land again with this cyclone at this time, but this feature that developed from the tropics, you have a pretty decent gradient of vorticity right across that, where that low pressure is located over Florida, and then the thermal wind is fairly strong. So you could assume that there would be pretty good PVA, positive vorticity by the thermal wind right where that storm is located, leading to a lot of ascent in that region, and forcing the strengthening of that feature as well. We go 24 hours now ahead of this. You see it only gets, let's go actually a little while back, maybe 12 hours back. Perfect. We can see here now we're at Sunday evening for us. Here's our low pressure. We still have that decent gradient and vorticity, very strong thermal wind at the base of this trough, so you could still make a case for a pretty intense PVA by the thermal wind right where that low is located. Maybe we have some sort of negative vorticity advection where this high is located, although the main vorticity strip is pretty far removed from where that is located at this time. We go, now let's go to 72 hours, please. It's hard to say if there's any negative vorticity advection, although there's pretty decent thermal wind across this high. We can see that the feature that is moving over the east coast, you can barely make out where it is. It's right here, which is over Pennsylvania, it looks like, but the vorticity gets all jumbled. You lose that decent PVA by the thermal wind. So that might not be happening in either of these locations at this time. And then if we go to 98 hours, or 96, yeah. This is when the ridge kind of overtakes the surface high, and we kind of get them stacked on top of each other. We don't really see any NVA by the thermal wind, but there still is a decent amount upstream of where that, or downstream of where that anticyclone is located. But this is sort of the max of this feature, and then it decays. And then you have these really nice troughs in between it. So very amplified flow as we go towards December 20th, but none of this impacts our weather, unfortunately. We get no snow, we get little rain. I think we're forecasted to not get really anything substantial, so we're gonna stay sunny and relatively warm for this time of year, unfortunately, but it'll make travel pretty nice. So maybe that's the upside, the only upside to not getting snow over the holidays, I would say. And then if we could I'll just end on this, if we could pull up pivotal weather, just get a Fantasyland forecast of the snow over our region for Christmas. Let's see if anything's changed. I know it hasn't, but we might as well check. If we scroll down to winter, and then we'll do the total 10 to 1 snowfall. And then let's just go to, let's see,
240 would be 10 days.
240, perfect. So from this model look, I mean, most of the United States, I don't think models do snow fairly well. I've noticed usually they say the max is like 4 or 5 inches of snow, and then that usually doesn't pan out. But this signal of no snow really anywhere in our region is probably what should be the takeaway of we might not get any snowfall, substantial snowfall at least. We might get snow flurries here and there, but a lot of the weather is over Canada and the eastern United States and then the Pacific, and we're in the middle of it. There we go. Maybe we get, let's see, in between Christmas and New Year's.
No.
Sorry.
The Dells does.
The Dells does, and we get 0, and then below us we have 4
Yeah,
inches.
then Rockwood gets 3 or 4.
Yeah. It's just perfect location for us.
Strip of
Right in
misery.
between.
Yep. I'm kind of hoping we go to the end of the calendar year without any substantial substantial snow. That-
Wow,
if
just to break a record.
Yeah, if we're so close, why not just do that? You know, just characterize the whole 2023 as washed out.
Fair enough.
Patrick, this was great, and
Yeah.
really, really interesting. And Andrea, if the, well, 6-week-old polar vortex gets displaced from an invasion from the east, so in the Atlantic, and it gets pushed off, is there a bias to where cold air outbreaks then go? Like, that seems to me to ensure that we don't get one in the central part of North America.
It depends. This seems like a wave 2 event.
Mm-hmm.
So that means that you have the ridge in the Pacific and the Atlantic.
Yeah.
So you get the polar vortex, like,
Oh, stretched.
split or
Yeah.
stretched. And those types of events tend to impact us more than just a push.
Then a displacement.
Yeah,
Oh, okay, so a
So-
singular feature that displaces it
right.
is different than 2 of them, even if
Yeah.
one of them seems to push it further than the other.
Yeah, so what really is interesting is that, everything tilts west with height.
Yeah.
So everything that's happening in the stratosphere is going to be in a completely different location geography-wise
Yeah.
than what's happening in the troposphere. And then that's sort of what is persistent, not necessarily what's happening in the troposphere.
Okay.
So because the stratosphere is so stratified,
Mm.
and there's no, smaller scale waves really causing any dynamic consequences.
Yeah.
It's those large scale ones that stay
Oh,
and
interesting.
sort of act as the boundary to keep the flow in this wave 2 ridginess.
Okay,
Yeah.
okay. I never thought of it that way. Thanks for that. Yeah,
But,
that's really
yeah.
interesting.
I mean, if we're talking about it, after the new year, there's a signal that things will get really interesting. So January could,
Really?
could be.
What is that page?
Oh,
of
yeah,
the-
it's Strat Observe, I think. Strat,
Sounds like stratospheric dreaming. Wasn't that the song by the Mamas and
yeah,
Papas?
that
That
was.
sounds.
So there's if you go to miscellaneous, and then, that one. This is the structure, the current structure of the polar vortex in the troposphere and stratosphere. And it's done by looking at I forgot the exact methods, but basically finding the strongest potential vorticity gradient at different isotropic surfaces going from the troposphere all the way
It's
to.
like the core exertel.
Yeah.
Yeah, so this is the GFS forecast, and if you look at forwards, you can look at the structure and you can see it wobbling across the polar cap. And then you can also see that we're starting to see it elongate, so you can kind of
Oh,
see
yeah,
the
yeah, yeah.
structure.
Yeah.
And so this is by Christmas, and so there's signals, and they've been pretty consistent for the last 2 weeks, that by New Year's, we might see a disruption.
Ooh, how
So,
interesting.
Yeah. And if that happens, then who knows?
All bets.
Yeah. Right.
Yeah, okay. El Nino be damned. Perhaps.
Well, I think El Nino, now I'm getting into S2S, El Nino and the MJO, their current phasing favored this wave 2 structure.
Oh, okay, okay.
Yeah.
So it's not be damned, but.
But it's sort of like,
Temporarily
it was just,
overruled.
the clock was ticking until
Okay.
it happened.
Okay.
Yeah.
Oh, this is really interesting.
Wow.
And it's great because you can like rotate it and look at it from different angles, and it's
Wow,
just a
that's
lot of
very
great
cool.
ideas.
Yeah, that is very cool. All right.
Anything else anyone wants to look at?
Great. Well, thank you, Patrick and Andrea and Pete. That's fascinating. Great one to end on.
Have a good break,
So
everybody.
that is making lemonade out of lemons, right there. Don't you think?
Yeah. So hopefully when we come back in January, we'll have
Yeah.
something to say about.
Yeah, right. I was saying to my class the other day, I think this is the first fall, but I've never kept track of it systematically, where we never got to talk about a snow event